Hey everyone, in this video we're going to talk about real-time analytical dashboards in Next.js. So if you're building an app and your app has a lot of data that needs to be analyzed or monitored, you probably need some kind of dashboard, and maybe you want to continuously update, basically real-time, right? Now in this video I'll show you some of the tools that you can use, some of the things you want to pay attention to. But I have to say, these days building a dashboard like this is much easier than it used to be. There are some new tools that make a lot of things much easier. So in this case, actually I have an example of, let's say, a web analytics dashboard. So maybe you are monitoring the data for a particular website or something like that. And there's continuously data here being streamed into the dashboard. So let's actually take a look and see how we can build something like this. All right, so we're using Next.js in this video. Now Next.js is a full stack framework, so it has both a client side as well as a server side. And actually this simplifies a lot of things. We don't need a separate backend. It's just one app essentially. Now to display data and have these graphs and so on, you probably want to use some kind of component library. And typically they are going to be client components, although they could also be server components. It's not really important. But basically for the UI itself, you probably want to go with something like, well, Shadcn UI is really popular these days. You've probably seen it around. This is a bit different from other component libraries because the code is not abstracted away from you. You basically copy paste the underlying code like this directly into your own code base. So then you can customize it exactly to fit your need. It's also completely based on Tailwind actually. So if you're already familiar with that, I think this is the way to go. But there are some other options as well, notably Tremor. Tremor is actually quite an underrated option in my view. But these are also some really nice components for charts, for any kind of dashboard. And actually it's interesting that they also recently joined Vercel. So Shadcn actually also joined Vercel. So now Vercel seems to really invest into these components for building dashboards. Now with Tremor, if we go to blocks and templates here, if you take a look at some of the blocks they have, which is basically just a combination of those components, a more fleshed out example essentially. They actually also provide you with the raw source code, you could say. Also nicely using Tailwind. So quite similar already to Shadcn UI, I would say. But those are some really modern options that I think definitely deserve to get a good look. I'm actually using Shadcn in this example. That's what I will use. By the way, the reason you want to use a component library in the first place is because they have worked on a lot of details that you don't have to think about anymore. So for example, if you have a dialog open like this, if I press tab, you can see it tabs between these buttons. So the focus, as it's called, is trapped within the modal here. If you don't trap the focus, if you press tab, it will actually just continue with the other things here on the page, right? So then it would tab perhaps this input field here. And also, of course, when I press escape, the dialog should close again. And the button that you clicked should be focused again, right? So there's all these little details that we don't have to think about anymore because the component library has already abstracted that away. Now, Shadcn is actually using Radix under the hood, and actually a lot of the abstraction is actually coming from Radix. So Shadcn is essentially just a Tailwind CSS layer over Radix in my view, but that's what makes it really good. So that's what I would use for the UI. Now these components that you see here, of course, they need actual data to have something to display in the first place. So the data will be coming from your Next.js backend. And if we want to make a so-called real-time dashboard, right? With real-time, I basically just mean continuously streaming in data. Typically, you want to have some kind of connection between the client side and server side. So we can use something like WebSocket, or what's actually also underrated in my view is server-side events. Basically, these two options will set up a connection between the browser and the server side. And this allows them to communicate continuously. Now, there are some slight differences between them. They each have their pros and cons. Typically, WebSockets are a little bit more cumbersome to set up. There's a little bit more work involved, but I would say they're a little bit more powerful. So with WebSockets, you can communicate from both server side to client side, and the client can also send back messages to the server side. So it's bi-directional. With server side events, it's a bit of an easier setup. There are some more limitations. So only the Next.js server side is sending messages to the client side, which in our case, if you're building a dashboard like this, because in a dashboard like this, I do not need to send messages from the dashboard back to the server again. It only needs to get data from the server side so then it can update the UI here. It's a bit easier to set up. So actually that's what I will use in the example in a second. Your Next.js server side, of course, will need some data source. Now, maybe you already have some data, maybe in your own database, maybe you're getting data from a third party, and that data may come in continuously. So maybe maybe somebody else is sending you continuously perhaps data. You can choose to put the data in a database, or maybe you immediately want to send it as a message to the client side using one of these protocols, or maybe both. You want to put it in your own database and also immediately send it to the client side. But you will need some kind of data source, right? Now, typically you will have some database and you will add data to your database, and you will also get data, read data from your database. What I will do in this app is we will add data to the database and then also read data from the database. When we read data from the database, we will then immediately send it to the client. Now, the database actually, in my view, is the most important piece, because as you'll see, a lot of these other things have been made very easy. A few years ago, if you wanted to build a dashboard like this would be pretty hard and there would be all sorts of bottlenecks here. But honestly, a lot of the rough edges here have been ironed out. The biggest gains you can get essentially, in my view, is by picking the right database. Now, there are actually different types of databases or ways to store data. So it's not just, oh, I'm just gonna pick Postgres, right? Or MySQL or SQLite even. You need to be a little bit more familiar with the different types of queries that your app is gonna make. So if you're an app developer, very often you are building apps that have relatively simple database queries. So as an example, you may be building an app and you need to simply create a new user in your table. So you would do something like insert into the users table user information, right? Just creating one row into our table. Or maybe you need to update somebody's email. So basically you're gonna get the particular row and you change the email, or just delete a user. And so these are relatively simple queries, and pretty much any database system can deal with these, right? So this is called OLTP, online transactional processing. So these are more transactional queries, very quick, one-off, one row, simple query. So if you're building a blog app or an e-commerce website or a to-do app, let's say, right? These are all typically the only type of database system you need is some kind of OLTP setup. However, for an analytics dashboard like this, you want to be a little bit careful with that. An OLTP database system is not optimized for a very analytical workload. So there is also something called OLAP, analytical processing. A database system like that is more optimized for an analytical type of work, and these typically involve aggregation. So for example, we want to see the average session duration among all the users, or we want to get all the user interactions on a form, let's say, between a particular date, right? So now you're not just dealing with one piece of data essentially in your database, you're dealing with multiple pieces of data. So data needs to be aggregated, it needs to be combined, maybe by date. So those types of queries can become much more complex. So some examples would be if you want to do some analysis for your e-commerce website, right? You would maybe get from a particular category all the sales and then group them by category. Or you want to see some trends in your data. Basically, you're combining multiple pieces of data and you're grouping it by some way, by date perhaps. And so this can get really, really complex. For workloads like that, you probably want to use an OLAP database system, right? So you need to be aware of this. Now, traditionally, this would be a problem because if you're building an app, you're probably going to have some simple queries, right? Your standard transactional query, creating a post in a database, editing a post in a database. You pretty much always need this. But then if you do want to add some analytical power to your app, or in a separate app but with the same data, you would need to find some separate solution. So then you would have perhaps one database for your standard queries, and then you would maybe have some other system for your analytical workloads. Very cumbersome. However, there are some solutions these days that actually allow us to stick to one database solution, and we can use both of these with the same system. So I'm actually going to use DuckDB in this video. We can use DuckDB in combination with Postgres, and DuckDB is what allows us to do these analytical type of queries efficiently as well. And we can just stick to using Postgres. So we can add DuckDB to our Postgres database for those analytical type of queries. It's open source. You can read all about it here on their GitHub page. Now, we could manually add it to our Postgres database and host it ourselves. It would be nice if that was taken care of for us. And that's where Hydra comes into play. They are today's sponsor, and they allow us to use Postgres with DuckDB, so we can use one database for our entire app with that powerful analytical capability as well. So I will use a Hydra database in my setup here. So Hydra is a high-performance Postgres database with that OLAP capability, we can use it both locally as well as a cloud offering, which I will actually use because it comes with a nice UI as well, so I can inspect my data. But if we take a look at the architecture that they have, basically what we can do in Postgres, of course, we create tables. So we can create a table under the analytics schema. So basically you have the analytics namespace. We're going to create a table in that namespace, and that table will automatically be optimized for us for analytical queries. And then if we want, we can also have our standard tables basically for our transactional queries, just like how you may be used to using Postgres. But now we get the option to add it to the analytics schema, and then we're using DuckDB here for those tables. You can read all about it here in the docs. It's actually really interesting, but let me show you how all of this now works together. So here for my database, a Hydra database, which is basically just Postgres with DuckDB for the analytics table, right? So I would say this is a really powerful setup for building real-time analytics dashboards. But let's actually take a look at some code and see how we would implement this. So I will go back here and I will delete. So let me actually go to the code here and let's try building this from scratch again. All right, so where do we start? Well, I removed everything and now we just have the homepage, which is almost empty. We just have a header right now. We just have web analytics dashboard. That's this H1 here. And here I want to display some information about the connection that it will try to make with the backend, right? So I'm just going to mark this as use client. So this will run in the browser, and we want to connect to the server so that we can receive data continuously here in the client side, here in the browser, so that we can then display it nicely with the Shadcn component. But right now there is no connection. I just hard coded this here. How do we set up a WebSocket or server-side event connection in Next.js? Let's start there before we actually install Shadcn and make it look pretty. Well, Next.js actually gives us the option to create a custom server. And this is actually a very underrated feature in Next.js in my view, because it allows us to set up a WebSocket connection and an SSE server-side events very easily actually. And a lot of people think it's not possible because Next.js is very focused around a request and response cycle, right? So there is some incoming request to the server-side response, and that's the end of it. And that is typically how a Next.js app works, right? So if you make a request, that's how it works. However, for continuously streaming data, we need some kind of connection like this, which is a longer running connection. So that's a little bit trickier to do in Next.js. However, with a custom server setup, we can still do that here. So let's actually see. So we need to create a server.ts file, so server.ts. And in this server.ts file, we can essentially create a server. So Next.js automatically, of course, since it has a backend, it has a server side, it would automatically do this by itself, regularly speaking, usually. However, here we can have some custom behavior when it starts the server. So in this case, for example, what we are doing is we are still sort of bootstrapping a Next.js server here. So we say next, and then we have the app. Then we call prepare on that, and in there we create a server. The regular Next.js requests will still be handled here. However, here we have a special route so that the client side will be able to start listening on this with this URL for our server-side event. And what are we doing in there? Well, we are just sending continuously messages to the client. So what we are doing here is every 3 seconds, we are just sending an object actually with a message in there, hello from server, right? This is just a very basic SSE setup here. And all the other Next.js requests will be dealt with, will be handled in the normal manner. Very similar to spinning up an Express server actually. Right, so basically just setting up some custom server behavior here only for this particular URL. For everything else, it's just Next.js as regular. Now, what can we do now with this URL? Well, now we can go to the browser here. So on this home page, what we can do here is we can say new event source. So sort of subscribe to that stream of messages that we'll be getting. When it's opened up, we'll display that here on the page as well. So we'll keep track of that here in state. But here is where we deal with all the messages that we'll be getting every 3 seconds or so. So we're just going to parse it and we're just going to add it to the messages array here, right? So in React, if you change the state, the component will re-render, which means if we scroll down a little bit, if we just re-render this whenever messages change, we can make this list longer and longer without refreshing. right? Because the state will automatically, because the state changes, everything here will re-render automatically. Now, if you try running the app with this setup here, it will not work yet, right? So here, it will just be in connecting forever. It will not be able to connect right now. You can see there's a 404, so it's not able to find it for some reason. So what we need to do to make this custom server work as well, we have to go to package.json here, and I'm going to change the dev script. So I'm going to start the app by actually running the server.ts file directly. Now I have TS node installed globally, and I will also set the type to modules here. With this, now it should work. So now if we run the dev script, if I stop the server here, I can still do npm run dev, and it's going to invoke ts node for the server.ts file. And now you can see ready on localhost 3000. So let's actually refresh here and see what happened. So let's see, it's connecting now. And yeah, so now you can see it's connected and it has already received the first message, and there's another one. So now every 3 seconds, you can see it's getting more and more messages. Now we have a server-side event stream in a Next.js app. I think that's pretty cool. We could have used WebSockets as well, but this will do for now. Right, so now we have a way of allowing the server side to push data to the client side. When the client side receives the data, we want to display it nicely with, in this case, let's use Shadcn. So let's quickly set that up here as well. Let me actually stop the server in the meantime so we don't get some infinite list here. All right, so Shadcn, we can use the terminal here. We can npx Shadcn at latest. First, we can initialize everything. It will try to create a components.json file, basically configuration for Shadcn, but it actually already found one. So actually, I already had it from the preparation here. So this will just specify how the components should be configured, like the color scheme and things like that. So you can see I picked Zinc. And then we can install the actual components. We can use the same command, but now it's add card but now it's add, and then it's card, table, and tabs. Those are the 3 components we will use. All right, so it has something about peer dependencies. Cool. So now if we take a look, it has actually added that in a new components UI folder here with all of the code here. So if we want to change something, we can do it directly in here, but we will leave these. Let's actually add them to our page. And with Shadcn UI, we also get this utility function, which helps with merging Tailwind classes. All right, so I added these components to the page. I changed the markup here. Right now we don't have data, but let's actually see what we get. So here now, if I go to our page, you can see we already get, well, bit of a boilerplate, you could say. It has some empty state for these cards and so on, but it already looks really nice. Now, of course, we want to work with our own data, and ideally it would automatically refresh or update the page as new data is coming in. And of course, we want everything to be as performant as possible, right? So now we have connection between client and server. We have our UI. Now we need to take care of our data. So what we will do with the custom server, we can make the custom server insert the data into our database. This can also be in an interval. So let's say every 5 seconds, it just inserts a bunch of data, just to seed the database continuously with some data. Of course, your data can come from anywhere. Maybe you already have a bunch of data, maybe you're using a third party. We'll need some way to add data to our database. We will also, every couple seconds, read data from the database, and that's what we will then pass over to the client side. Now, if you want to try out Hydra locally, if you go to start.hydra.so, you'll find a quick start here where you can install Hydra and start playing around with it locally. However, I will actually use a hosted Hydra in this video. So I'm going to use a Postgres database managed for me by Hydra. And again, the benefit is that I can create tables inside an analytics schema here, which will then use DuckDB under the hood. And so they're going to be optimized for my analytical queries. I can still use my normal tables, right? Let's say I have some post table here. I just created this as an example. This would still be my transactional queries, my standard queries. However, for the data that really needs that analytical power, I'm going to put the tables in here. You can see currently there are no tables yet here. So how do we add the tables here? Well, to actually interact with my database, I do like to use an ORM. If you're an app developer, you may be using Drizzle or Prisma. In this video, I will use Prisma. So with Prisma, I can define my tables here as a model. So the data will be about some kind of web analytics. So there's going to be sessions. I want to create these tables as part of the analytics schema, right? So I can specify it like this. There's going to be page views. So there's going to be page views in a particular session. And there's also going to be interactions, right? So here, these tables are connected. By the way, if you have a table that is inside the analytics schema and another table that is not inside the analytics schema, you can still join them together actually with Hydra here. So you don't have to worry about that. Anyway, these are my models here. These will become tables. So let's actually push that up. So I can do npx prisma db push. Prisma will try to connect to my database. Right, so here you can see now my database should be in sync with my Prisma schema. So now if I go back here and refresh, you can see here now I have 3 tables, one for interactions, page views, and session. Cool. By the way, my connection string, everything you can find here in the dashboard. And actually I'm using Prisma here, but you can see there are other ORMs available. But I'm using Prisma here. Make sure you don't show your secrets to anyone else. I will delete it after recording. All right, but now of course my tables are still empty. There is no data in the database yet. So we need to seed the database with some data. So what we're going to do is when we start our app, we're going to call this function here, generate dummy data, which will just insert a bunch of dummy data every couple seconds. So in this function, what are we doing? We just have some options here, some page URLs, some dummy data here, and that is what we are inserting every 5 seconds, right? So here we're setting up an interval, and here it creates a session that we specified in our table, right? The exact, right? So it's just creating some random data, adding some, making it a more random distribution here. It's creating some page views for each session and then the interactions, right? So we have something for each table, and actually it will update the active sessions as well, but eventually it's gonna update the actual database here, and also here it will create data for the page views and also for the interactions, right? So there's a bunch of dummy data here, right? So there's a bunch of stuff in there, but basically just adds data to our database every 5 seconds. When the Next.js server starts, every 5 seconds, it will actually populate the database with some data, but our UI doesn't know about that, right? So what we also need to do is we need to read data from the database. So here where we were sending a message to the client every couple seconds, we need to change it a little bit. So we're actually getting some data from the database. So I actually put it in a separate function as well. So here, every 3 seconds, we're going to go into our database. We're going to have some query. Let's say take 10. We want to order by something, maybe include it with some other data. And again, here we can have some really complex queries, right? Really analytical type of queries. We can do a bunch of aggregation. So here, for example, we're going to group some things here, count some things, and we can make it much more complex if we want. Right? And here we're going to check the sessions that either ended or not ended yet, and order them, and so on. Right? Of course, we can make it much more complex. Let's actually see if all of this works now. So now if we start our server, let's see what happens. If I go back to our page here, and actually I will make it port 3000, but let's actually try this. If we now run the app here, and now if we go to our page here, let's see what happens. Hopefully everything works. And here we go. Okay, so here we have our boilerplate again, and let's wait a bit, a couple seconds. And here you can see we are now getting data here into our app here. You can see it's automatically updating here. I don't have to refresh or anything like that. So you can see it is able to get that data from the database, right? So this is not hard coded. We are actually getting data from our database, right? Yeah, I think this is really nice. If I actually go to my Hydra dashboard here, if I refresh, you can see we have all of our data here automatically added every couple seconds or so. And so this data here will be optimized for analytical workloads, right? So we can go pretty crazy here. We can make it much more complex, but I think you get the point, which is that by using, in this case, Hydra, which is basically Postgres with DuckDB managed for us, we are able to have one database for both the transactional as well as analytical. And it fits in really nicely with the overall stack here for real-time analytics dashboards with Next.js. And yeah, overall, it's really mind-blowing to me how powerful, how sophisticated the apps and software is that we can build these days as developer using all of these tools. If you tried to build something like this a couple years ago, it would be so much work, but these days it's actually very doable. So actually I think it's a great time to be a developer. So hopefully this helps you out with building your dashboard. In any case, I want to thank you for watching, and I want to thank Hydra for sponsoring the video. Check them out. You can find a link in the description, and I will see you in the next video. Have a nice day. Bye.